Hello, good morning everybody. I'm Dr. Hema Harris. Today we're going to learn about the cranial fossae. Singular is fossa. Since they are three in number, we call them as cranial fossae. Now, what is cranial fossa? The internal surface of the skull or the interior of the base of the skull is divided into three compartments. So it is actually naturally demarcated into three parts, and each of the part is called a fossa. So depending upon the position, we have an anterior cranial fossa, middle cranial fossa, and posterior cranial fossa. Now, what is the base of the skull? We said it is the interior of the internal surface of the base of the skull is what we call the cranial fossa. Now, base of the skull is that part where the neurocranium, the whole of the neurocranium without the skull cap. Once the skull cap is removed, whatever is left behind is called the base of the skull. So we are viewing it from the inner surface. We are viewing the cavity inside. So that is the internal surface of the base of the skull divided into three fossae: anterior, middle and posterior. Here we can see the demarcations. What we see here, the anterior most, this is the anterior part and this is the posterior part. And here what is in the anterior part is the anterior cranial fossa. Behind what is marked in purple is the posterior cranial fossa, and what the area between the anterior and the posterior cranial fossa is called the middle cranial fossa. That is anterior, middle and posterior cranial fossae. First we shall see the anterior cranial fossa. The area marked in green is the anterior cranial fossa, this part. Let us see the boundaries. Boundaries are anteriorly and laterally we have the frontal bone. See, this is the frontal bone anteriorly as well as on either side. This is the frontal bone. Posteriorly, so this is the posterior aspect, what is given in dotted lines. Posteriorly, we have the posterior border of the lesser wing of sphenoid. This is the sphenoid bone, and here is this is the lesser wing. Okay, this is the lesser wing, and what is marked in the dotted line is the posterior border of the lesser wing of sphenoid on either side. These two are the posterior border of the lesser wing of sphenoid. Also, posterior border is also formed by the anterior clinoid process. You see a small process here. This is the anterior clinoid process of the sphenoid bone, and this is the sulcus chiasmatis. So the anterior, the dotted line shows the anterior margin of sulcus chiasmatis. Hence, the posterior border is formed by the posterior margin is formed by the posterior border of the lesser wing of sphenoid, the anterior clinoid process, and the anterior margin of sulcus chiasmatis. Whereas the anterior and lateral borders are formed by the frontal bone. Now let us see the floor. This is the floor. Floor can be divided into a median, not medial, median region, that is the central part, and the lateral region. The midline part is the median region. In the midline region or the median region, what constitutes the floor? Anteriorly, we have the cribriform plate of ethmoid. You see here, this is the cribriform plate of ethmoid, and posteriorly is the jugum sphenoidale. This is the jugum sphenoidale. What is jugum sphenoidale? You have studied sphenoid bone, right? This is the anterior part of the superior surface of body of sphenoid. So this is jugum sphenoid. Then laterally also you can divide into anterior and posterior part. Anteriorly, this part on either side is formed by the orbital plates of frontal bone. These two are the orbital plates of the frontal bone, and posteriorly we have the lesser wing of sphenoid. This is the lesser wing of sphenoid. So that explains the boundaries of the anterior cranial fossa. Here we're just mentioning again what the boundaries are: anteriorly and laterally frontal bone, posteriorly the posterior border of the lesser wing of sphenoid, anterior crinoid process, and anterior margin of sulcus chiasmaticus. Here the floor is shown again. This is the floor where you have the median region and two lateral regions. In the median region you have the cribriform plate of ethmoid bone, and posteriorly this is the jugum sphenoidae. This area is the jugum sphenoidae. And laterally we have the orbital plate. This is the orbital plate of the frontal bone on either side, and posteriorly the lesser wing of sphenoid. Now let us see the features and attachments of the anterior cranial fossa. What we see here is a frontal crest. Frontal crest is a median crest in the anterior wall of the fossa. So a median elevation in the anterior wall of the fossa is a frontal crest. We have the attachment of falx cerebri here. Further behind, what you see here is the crista galli. Crista galli is a part of the cribriform plate of ethmoid. This is a cribriform plate of ethmoid bone, and an upward tooth-like projection from the cribriform plate is the crista galli. The crista galli also gives attachment to the falx cerebri. So the frontal crest and the crista galli provides attachment to the falx cerebri. Next feature is a foramen cecum. Foramen cecum, it is a foramen which is situated between the crista galli and the frontal bone. This is the frontal crest, what you see here, and this is the crista galli. In between the two, there is a small opening which is called the foramen cecum. Foramen cecum is usually a blind opening, that is, it doesn't usually transmit something, but occasionally it can transmit emissary vein from the nasal cavity to the superior sagittal sinus. Another feature is the cribriform plate of ethmoid. We had mentioned in the previous slide that this bone here, this bone is a cribriform plate of ethmoid, and crista galli is a part of the cribriform plate of ethmoid. Now you can see multiple openings here on the cribriform plate. It is called cribriform because of the multiple openings which gives a sieve-like appearance. It is a perforated bony plate, and there are about 15 to 20 filaments of olfactory nerves passing through each perforate plate from the olfactory mucosa of the nose to the olfactory bulb. So from here we can see there are 15-20 filaments through each plate. Then there is a groove which is just lateral to the crista galli. The lateral to the crista galli, here there is a groove which lodges or which is related to the olfactory bulb and the gyrus rectus. This feature here, this part of the brain, this part of the gyrus is the gyrus rectus, and there is an olfactory sulcus where you have the olfactory bulb. So these two areas are related to the lateral part, that is a groove which is lateral to the crista galli. Next feature we can see is the jugum sphenoidale. As we said earlier, this is the jugum sphenoidale. This is the sphenoid bone, and here the most anterior part of the superior surface of the body of the sphenoid is called jugum sphenoidale. This is jugum sphenoidale. The anterior margin, this is the anterior margin of the jugum sphenoidale. The anterior margin meets the posterior margin of the cribriform plate. We had seen that the cribriform plate of ethmoid was coming here. So the anterior margin meets the posterior margin of cribriform plate of ethmoid, and posteriorly it is limited by the sulcus chiasmaticus. This depression here is the sulcus chiasmaticus, and the anterior border of sulcus chiasmaticus is the posterior limiting end. Next feature we can see, not in this, but another feature we can see is the orbital plate of frontal bone. I had shown this in one of the pictures earlier. On either side there is a pair of bone forming the floor. The floor was formed by the floor on the lateral side was formed by the orbital plates of frontal bone, and these plates separates the anterior cranial fossa from the corresponding orbit. Also, there are multiple impressions on this plate of bone for the cerebral gyri. This part of the frontal bone supports the orbital surface of the frontal lobe of cerebrum. And posteriorly, the orbital plate of frontal bone meets the anterior margin of the lesser wing of sphenoid. Next important feature is the lesser wing of sphenoid. Here, the part that is marked in green shows the pair of lesser wing. This is the sphenoid, and here we have the two lesser wings. Now this is we said earlier, this is a jugum sphenoidale. Jugum sphenoidale continues on either side laterally with the superior surface of the lesser wing. We can see that it is broader medially and tapers as it goes laterally. The posterior margin, so this is the posterior margin of the lesser wing, is related to two structures. One is the sphenoparietal sinus and the lateral sulcus of cerebral hemispheres. Further, the posterior border of the lesser wings, as we trace it medially, we can see there is a projection here on either side. This is called the anterior clinoid process. So the posterior border traced medially ends in the anterior clinoid process, and this anterior clinoid process gives attachment to the free margin of tentorium cerebelli. Free margin of tentorium cerebelli. So we have completed the anterior cranial fossa and we are starting the middle cranial fossa. Middle cranial fossa, we said earlier, lies between the anterior cranial fossa and posterior cranial fossa. The area marked in green, this area between the two sets of dotted lines marks the middle cranial fossa. So what are the boundaries? We have an anterior boundary, a posterior boundary, then we have lateral boundaries, floor also divided into a central portion and a lateral portion. So we shall see each of the boundaries in detail. Let us see the boundaries of the middle cranial fossa. Anteriorly, see these black dotted lines forms the anterior boundary. What are they? This is the posterior border of the lesser wing of sphenoid. We saw earlier that this was the jugum sphenoidale, and from here we had the lesser wing of sphenoid on either side. So the posterior border of the lesser wing of sphenoid. Then here we have the anterior clinoid process and the anterior border of sulcus chiasmaticus. This forms the anterior border. Posterior border, these dotted lines form the posterior border of the middle cranial fossa. Here we have the superior border of the petrous part of temporal bone. Now this is the petrous part of temporal bone. You have covered the petrous part of temporal bone along with the temporal bone class, which was uploaded 2 days back. Sorry, not 2 days back, a week back I think. Now here this is the petrous part of the temporal bone. It has a superior border. This is the anterior surface in front, and this is the posterior surface of the petrous part. This is the apex and this is the base. Now here the superior border of the petrous part of the temporal bone forms part of the posterior boundary. Then we have here, this is the posterior clinoid process and the dorsum sella. So dorsum sellae, posterior clinoid process, and the superior border of the petrous part of the temporal bone forms the posterior boundary. What about the lateral boundary? This is a lateral boundary. So on each side we have the greater wing of sphenoid. This is a greater wing of sphenoid. Then this green colored bone is the parietal bone. We have the anterior inferior angle of the parietal bone. This is the anterior inferior angle of the parietal bone. Then here we have the squamous part of the temporal bone. So the greater wing of sphenoid, anterior inferior angle of the parietal bone, and the squamous part of the temporal bone forms the lateral boundary. Coming to the floor, this whole thing is the floor. Floor has a central portion and on either side lateral portions. Central portion is formed by the body of sphenoid. This is the body of sphenoid. Lateral portion, what do we have? This yellow bone is the greater wing of sphenoid. The purple bone is the squamous part of the temporal bone, and here this area is the anterior surface of the petrous part of the temporal bone. So floor is formed in the center by the body of the sphenoid, and on the lateral side by the greater wing of sphenoid, the squamous part of the temporal bone, and the anterior surface of the petrous part of the temporal bone. So that covers the boundaries and the floor of the middle cranial fossa. This slide explains what we mentioned earlier about the posterior border being formed by the superior border of the petrous part of temporal bone, posterior clinoid process and dorsum sellae, and the lateral border occupied by the greater wing of sphenoid, anterior inferior angle of parietal bone, and the squamous part of temporal bone. The floor has a central portion formed by the body of sphenoid and a lateral portion formed by the greater wing of sphenoid, squamous part of temporal bone, and the anterior surface of the petrous part of the temporal bone. Let us see the features and attachments of the middle cranial fossa. Now here, this is the sulcus chiasmaticus. Sulcus chiasmatis. This depression here, this groove what you see here is a sulcus chiasmatis. It is just behind the jugum sphenoidae. This is the jugum sphenoidae, the anterior part of the superior surface of the body of the sphenoid, and just behind that there is a transversely running groove called the sulcus chiasmatis. It is called chiasmatic because it is related with the optic chiasma. The optic chiasma lies posterior superior to the sulcus. So because of its relation with the optic chiasma, it is called sulcus chiasmatis. Now if you trace it laterally, the sulcus chiasmatis leads laterally into the optic canal. What you see here is the optic canal. So the optic canal connects the middle cranial fossa. This is the middle cranial fossa. It will connect the middle cranial fossa with the orbit. We know that the orbit is here. So the optic canal connects the middle cranial fossa with the orbit, and it transmits three structures: optic nerve, ophthalmic artery, and the meninges. Next feature is the tuberculum sellae. So here we saw the sulcus chiasmaticus. This is the sulcus chiasmatis. Here this was the jugulum sphenoid. Behind the jugulum sphenoidale we saw the sulcus chiasmatis, which was leading into the optic canal on either side. Just behind the sulcus there is an elevation. You see this elevation of bone? There is an elevation behind the sulcus which is called the tuberculum sellae. Tuberculum sellae. And when you trace it laterally, when you go towards the lateral end of the tuberculum sellae, on either side you can see a prominent end which is called the middle clinoid process. I have taken it in this diagram. This is the tuberculum sellae. When you go to either side laterally, each side has a prominent end which forms a middle clinoid process. We had seen the anterior clinoid process and the posterior clinoid process earlier. So this is the middle clinoid process. Now, what is attached to the tuberculum sella? The anterior margin of the diaphragma sella. The diaphragma sella is a sheet of dura mater, and that covers this area. So the anterior margin of the the anterior margin of the diaphragma sella, which is a sheet of dura mater that gets attached to the tuberculum sellae. So this diaphragma sella, this actually covers the, or it forms the roof of the pituitary fossa. What is the pituitary fossa? We'll learn soon. So this area behind is the pituitary fossa, and this sheet of dura mater, which is called the diaphragma sella, covers the or forms the floor of the pituitary fossa, and the anterior end of the diaphragma sella gets attached to the tuberculum sellae. Clear? Then we have sella turcica. Come further behind. Come further behind the tuberculum sellae. This is the tuberculum sellae. Behind the tuberculum sella is an area called the sella turcica. So here you can see this area is the sella turcica. That is actually a depressed area behind this elevation of tuberculum sellae. So this depressed area is called so. It is called the sella turcica because it resembles a Turkish saddle. Now, this depression has a deepest part. So the deepest part of the sella turcica is called the hypophyseal fossa or the pituitary fossa. What we just mentioned, this deepest part of the sella turcica is called the hypophyseal fossa or the pituitary fossa, and what is lodged here? The pituitary gland. Okay, so this is the hypophyseal fossa or the pituitary fossa lodged in the pituitary gland. So here this forms the floor of the hypophyseal fossa. Below the floor of the hypophyseal fossa lies the sphenoidal air sinuses. We have heard about the other sinuses, which are the maxillary, frontal, ethmoidal, and one more is the sphenoidal. Sphenoidal lies below the floor of the hypophyseal fossa. Next feature is the dorsum sellae. Now here we just finished the sella turcica, right? So sella turcica, we said, is a depressed region, and the deepest part forms a hypophyseal fossa. Behind the sella turcica, there is a square plate of bone. See this bone? This square plate of bone is called the dorsum sellae. So the dorsum sellae forms the posterior part or posterior margin of the Turkish saddle. Now when you trace the dorsum sellae laterally, you can see that these superior angles on either side, the superior angles project forward and laterally to form the posterior clinoid process. So these are the posterior clinoid process. We had seen the anterior clinoid process in the lesser wing. Middle clinoid process we had seen earlier, extending from the side of the sella turcica, extending from either side of the tuberculum sellae, and this is a middle clinoid process, and here from the dorsum sellae arises the posterior clinoid process. Diaphragma sella is attached to the upper margin of the dorsum sellae. So the anterior margin of the diaphragma sella was attached to the tuberculum sellae, and the posterior part is attached to the dorsum sellae. The anterior margin of the attached margin. See, there is a free margin and the attached margin for the tentorium cerebelli. The attached margin of the tentorium cerebelli is attached to the posterior clinoid process. We had seen earlier that the free margin of the tentorium cerebelli was attached to the anterior clinoid process, but the attached margin of the tentorium cerebelli is attached to the posterior clinoid process. Next feature is a carotid sulcus. Another name for the carotid sulcus is either carotid groove or cavernous groove. Can you see these two depressions, shallow depressions on either side of the body of the sphenoid? This is the body of the sphenoid. On either side you can see two depressions. In this picture also, see these two shallow depressions on either side of the body of sphenoid. That is called the carotid sulcus or cavernous groove or carotid groove. This groove or sulcus lodges the cavernous sinus enclosing the cavernous part of internal carotid artery. When you trace it posteriorly, when you trace this depression or the sulcus posteriorly, it reaches up to the foramen lacerum. This is the foramen lacerum. So when you trace the carotid sulcus posteriorly, it reaches up to the foramen lacerum. Another important feature is the superior orbital fissure. This opening here, it is a triangular opening which connects the lateral portion of the middle cranial fossa. So we know that this is the central portion and this is the lateral portion of the middle cranial fossa. So the lateral part of the middle cranial fossa is connected to the orbit. Through this goes the orbit. So this fissure, the superior orbital fissure, communicates the lateral part or lateral portion of the middle cranial fossa with the orbit. What are the boundaries? It is bounded above by the lesser wing of sphenoid, below by the greater wing of sphenoid, and medially by the body of sphenoid. These are the boundaries. What we are seeing here is the superior orbital fissure. See this triangular area is the superior orbital fissure. The superior orbital fissure is divided into three parts: a lateral, middle and medial part by the common tendinous ring. You see this ring here? This is the common annular tendon or tendinous ring of Zinn, Z-I-N-N. Now this common tendinous ring or the tendinous ring of Zinn is attached to a small projection on the lower part of the superior orbital fissure. Thereby this tendinous ring divides the fissure into three parts. Now what is this ring? Why do we call it common tendinous ring? This ring is a fibrous tissue. It is made up of fibrous tissue surrounding the optic nerve. This is the optic nerve. This fibrous tissue surrounding the optic nerve where at the apex of the orbit. And it is from this fibrous tissue that 6 of the 7 extra muscles take a common origin. There are 7 extraocular muscles, of which 6 of them take a common origin from the common annular tendon of Zinn. So which are the muscles? Here you have the superior rectus, this is the inferior rectus, this is the medial rectus, this is the lateral rectus, here you have the levator palpebrae, and this is the superior oblique. So all these 6 muscles take origin from a common tendinous ring, and this ring divides the superior orbital fissure into 3 parts. Now let us see what passes through each of these fissures. So here you have the lateralmost part, you have the lacrimal nerve, then you have the frontal nerve, this is the trochlear nerve, this is the superior ophthalmic vein. In addition, you have 2 arteries also in this region. Then in the middle part, you have the third nerve, that is oculomotor nerve, superior and the inferior oculomotor nerves, nasociliary nerve and the abducens nerve. And in the medial part or medial area, you have the inferior ophthalmic vein and some sympathetic plexus. The slide explains what we just discussed with the picture. So here we're just narrating the structures passing through the lateral part. We have the lacrimal nerve, frontal nerve, trochlear nerve, superior ophthalmic vein, and I said there are 2 arteries also, middle meningeal branch of lacrimal artery and orbital branch of middle meningeal artery. Through the middle part passes the upper and lower divisions of the oculomotor nerve, nasociliary nerve and the abducens nerve, whereas through the medial part the inferior ophthalmic vein and the sympathetic plexus passes through. Next we can see the foramen. One is foramen rotundum. Foramen rotundum is present in the greater wing of the sphenoid. It lies behind and below the medial end of the superior orbital fissure. So if this is the medial end of the superior orbital fissure, here you see the foramen rotundum, and this is the greater wing of the sphenoid. It transmits the maxillary nerve. Further below, posterior lateral to the foramen rotundum, there is a foramen ovale. This foramen is oval in shape and hence the name foramen ovale. It transmits the mandibular nerve, accessory meningeal artery, lesser petrosal nerve and the emissary vein. The next foramen is foramen spinosum. So you can see that this is a very small foramen which is posterior lateral to foramen ovale. This is foramen ovale. Posterior lateral there is a small foramen that is called the foramen spinosum. And foramen spinosum transmits the middle meningeal artery, middle meningeal vein and nervus spinosus. There is another a bit irregular foramen called foramen lacerum, which is situated between the sphenoid and the temporal bone. So this is the petrous part of the temporal bone, this is the squamous part. So between the temporal bone and the sphenoid bone there is an irregular foramen called the foramen lacerum. Structures passing through the foramen lacerum are only two: meningeal branch of ascending pharyngeal artery and an emissary vein. This foramen opens into both the carotid canal and the pterygoid canal. A nerve known as the nerve of the pterygoid canal or the Vidian nerve is related to the foramen lacerum. So this Vidian nerve lies in the upper part of the foramen lacerum. Then we can see the features on the anterior surface of the petrous temporal bone. Some of them are the trigeminal impression for the trigeminal ganglion, arcuate eminence, which overlies the anterior semicircular canal of the internal ear. Then tegmen tympani, a thin plate of bone which covers the rest of the anterior surface of petrous bone. Then there is a superior border of the petrous bone. There is a petrous part of the temporal bone. It is grooved by the superior petrosal sinus, and the margin of the groove gives attachment to the tentorium cerebelli. These features have been dealt in detail in the petrous part of the temporal bone. So with that, we have completed anterior and middle cranial fossa. Then in the next PPT, we shall cover the posterior cranial fossa. Make sure you watch the next PPT also. Thank you.